bunch of other things, flat fan, like for other equipment. We really only work with the digital version of this, which is, I think it's the exact same thing, it just has a digital readout. For the most part, it's pretty restricted on the inputs back into the controller for the control. So this is just about the only one that we offer for set-point control.
So that's a good point. There's only two space sensors we accept. The BaseSense 036A and BaseSense 074A. Any other sensor from Trane the unit will not accept that we know of unless...
Asterisk.
Huh?
Asterisk.
Asterisk. Yeah, we could, but those are the only two that we have approved, that we have tested and tried.
There's a digital version. So I need to get that one.
I've never seen it. So this, I'm laughing because all the thumb wheels that we had to put in, we connected straight to the, I think, the UC 600.
Mm-hmm.
So, are you saying we could just go?
Yeah, yeah. Pretty much anything that's installed in the field, we have a field wiring terminal.
Oh man.
What is the out?
Oh, so it is this device here.
I wanted to know for like 2 years. No one's been able to tell me.
OAU, outside air unit terminal strip.
Thank you. That was so much easier.
So what he's referring to is this terminal strip here that's installed on all units.
Yeah. So that's where all the
Outdoor air unit terminal strip.
so that's where all the field wiring terminal strips, or all the field wiring should be landed, except for the back. The back net is the one that goes straight to the device. So any field installed device, we have a spot on the terminal strip. It must have been a lot more.
Oh yeah,
No one
yeah.
had been able to explain it.
Crazy. I don't know why-
What OATS means? Yeah.
That's all I wanted to know.
And if you ever start up an RRU, we have RRUTS, which is Restaurant Rooftop Terminal Strip. Restaurant Rooftop Unit Terminal Strip.
So
And by the way, I do know make mention, Horizon is not an RRU.
oh yeah,
They're different. We
Yeah,
got a
this-
few questions about that.
This is Horizon startup only. We also modify Voyager's precedents, but this is not for RRU setup whatsoever.
Yeah. This is not for that. They're kind of similar, but the program is all different, and they don't even apply to each other.
So don't call me if you have an RRU question. I'm just kidding.
Totally calling you.
Well, I used to be a tester for the RRU, so I know how they work. I just don't like answering questions on them. So this is the full, like, if you had all the options, this is everything that can be wired up to the terminal strip. So this is just all the different things. Some of them are wired on the like the back side of it where it won't be field installed. So that 20-volt AC and the chassis ground on 2021, so that's something that we wire on. It's used for whenever you hook up other devices to control, like or to power the duct static sensors and things like that. So
Okay, so maybe what we did was we maybe had a unit that didn't have the it wasn't set up for thumb wheel. We actually had to create the point and then wire it to the controller. I guess because of maybe that's what.
yeah. So for so if it's everything that's at the multi-zone VAV, we always wire up for the field for the space sensors. We always wire those to the field wiring terminal strip. Yeah, because it's just we get switched. People order discharge air control, switch over to space control so frequently. We just wire those wires every single time to make it easier for you all when you all go to the field install.
Oh, okay.
I took it off, and Jimmy gave me a really hard time until I finally added it back because I guess you all complained about it enough that he got tired of hearing it. But yeah, so basically for discharge air control, we still wire those wires with the space sensors on there. And all these wires, the wiring diagram is built per unit. So the wiring diagram, for what you see in the unit, is specific to just that unit. And so if it's on the wiring diagram, it should be in the unit. So if you're wondering whether those wires are there or not, you can always pull up the wiring diagram and see it, whether they go to the oldest board from the XM70.
Did the new diagram come from the PPS program? Because I noticed when you got that program, you got a different diagram.
Yeah, that's when I took over the wiring diagram. And so whenever it switched over to PPS is when we changed the whole template of the wiring diagram.
Okay.
And that's where the new one. And once we switched back to the KCC program, we still kept that new wiring diagram.
Okay, that's good.
Yeah. So basically, when we relaunch PPS, it's backwards compatible. So you don't have to change any of the wiring.
Oh, great.
So we updated our programming to match the PPS wiring, and then when we switch back, it all work together.
Digital lost their mind when that happened. They had all these.
Yeah.
Oh, I
You remember
that?
that? They
Yeah.
lost their mind.
Well, I've been in contact with him with this new program update too, just because it changes some of the point configuration, and I want to make sure that they're ready for changing set points and things like that. So I've been in communication with them. There's a couple of big companies that buy a lot of units throughout the U.S. and we try to make sure that we communicate these type of changes. So this is all the different program versions and when we made the update. There's a few pages inside of here, and there's like just a general brief description of what we changed with each one of the programs. I will say, just in general, all the way back to 7.0, that point list that you all have, it says 8.0, but it's pretty much the same all the way back to 7.0. There's not a whole lot of changes. Before 7.0, the only real difference was that we had the, you see where it, I would say like the instance values on before 7.0 probably aren't correct, but it's still not a bad general rule of thumb. I have some points lists in there for some of the other programs on that thumb drive, but if you're just trying to get a general idea, you can always use that points list all the way back to 7.0. So with 10.0 was the release of PPS, and there's a few other notes in there, things that we added with PPS, like there's some switches and things like that that PPS wanted to align with train standards, and so we added it when we released 10.0.
I haven't seen PBS. What is it? You still use TU? Do we have a new program?
So PPS, it still looks the same as far as you still use TU to access it. What it is, instead of using our default, PPS is train prepackaged solutions. What it is, they offer a bunch of different, they have software that helps build different things, and it helps on the sales side for train. What we used it for was the PPS configurator, which builds programs, and it built programs that are specific to each one of the units. So it only had TGPs and points that were used on that unit. So it looked at the model number and put together what was needed. So there was only a few points that were used in PPS programs that weren't used in the units. For the most part, if you've seen 10.0 where you see PPS program in a unit, then it's only the programs that are used for that. Those options are in there.
Take a break real quick, get started. So we're gonna take another quick 15-minute break, and then we'll probably try to power through this, finish around 4 o'clock, because the buses will be here at 4:30, so we can go eat. So we're gonna try to get through some mechanical stuff, and then tomorrow morning we'll do a plant tour, come back, so you guys do controls some more, and then go back out and do startup on the units themselves. So we're gonna try to break it up a little more for you, so we're not so heavy at controls for the whole day.
He is. We're in the very back.
You put baby in the corner.
Yeah, we're the way we like to say it is we're close to the test stand, so we can go out there and interact with kids. But so are they coming? Do they have season?
Move something up. We're the ones that started doing that kind of thing.
Yeah, because they asked us to do a bunch of custom sequences. There's a lot of back and forth, and then they probably just decided we're going to forward no controls and take controls and not to do it. There was that. Never really. We used to do a lot of those. They would add controls that feel like we did a lot better communicating with those, like when they were no controls and saying, hey, just so you know, this isn't like a thermostat control. This is you'll need a controls contractor to set this unit up. We have done a lot of people buying no controls, and they end up just buying controls for this, which is really expensive to live in. But
Yeah, no, they're having to get that picture. Because they're having to get our control guys.
yeah. But yeah, I mean, So, our actual stance has to be controls guy, mechanical guy, but I think, somebody, I think it needs to be a mechanical person. If that person can navigate tracing to you and understand the sequence of operation, I think understanding the sequence of operation is important, just how the unit should operate as a, broad overview. And then if they can navigate tracing to you, so basically somebody who's played around with tracing to you can understand sequence operations. Kind of needs to be a mechanical person. It's like this mechanical person can typically start a unit if they know the T. Controls guys can't typically start units because they don't have gauges and they just refrigerant charge and any of that type of stuff. So,
10 and 1 laptop. Usually a 10 and 1.
yeah, yep. I've had people call me during startup and I'm like, all right, what's your learn they're having a refrigeration problem? And then I'll say, what's your supplemental speed or what's it doing right now? Like, I don't know. I'm hooked up through the SC system. I don't have any gauges, so. I think on every unit, set points are also going to have to be made and have to be adjusted. Space control, like I said, it's a little bit too forgiving, especially if they have a VAS system that writes the space at that point to the unit, then you probably don't have to make adjustments. What's that?
For that configuration, so that's with the multiple units. Setting the max. With that submittal, that was. So what are you doing? Can't you still max under your?
Yes. So if you look at like the decision matrix of the new program, if it has an ERB, so it'll disregard the outer risk points if it has an ERB, or if it has a lot of return. So if it's 100% not there, but it has an ERB, then the new program is going to disregard the outer risk points. But so it's an or situation. Yeah.
So either way, in space, you are going to max it.
Forever a guy, let's go,
Yeah, so in the new program, all it does is, yes,
You still have that.
no, it'll do it. So what it does is,
You're at that point,
new program that there's basically like a binary, a local binary for the program that if it's going to read, say like, do we have an ERB or is the minimum deposition is it below 80%? And it's going to just tell the program to disregard all the operations. So.
So basically, safe side in space,
Yeah, except except for units that are don't have an ERB and then close to 100% outside there, then we're going to just offset the space outputs.
And is that so when you say areas, add 15, start your code
Yeah.
Is there a formula for non-ERD space? Or is that just
The thing about discharge control that I've found, it seems like engineers expect that a lot. Like it seems like space control, let's just say, I just really control space. Discharge control, let's say, I want to go like cooling, or just do this, and I'm heating, so it seems like they specify that a lot. But that's something we don't. Discharge control is probably, space control used to be the hardest to set up, that's what it is. In the future,
Go to that little green tab.
multi-zone, so I haven't run it outside the discharge control, but multi-zone is trying a different control level. It's actually controlling the discharge regardless of what the outer risk points are.
Oh, you gotta do the dot.
Yeah, so in that case, I would just, like, so if they want 70 degrees in the space, I would just offset it a little bit. So, if they want 70, just do like 85 milliliters.
Try TS HOU 725. Got it, I'm giving you mine. TS HOU 725. No, not.
Well, so for print shop,
Go back up.
they're
Oh,
using
okay.
it, so they may be okay with
I
it.
can't even see it. But I'm-
725?
Yes.
Okay. Go by last word. One, no,
Try.
Well, see, that's an example. Was that an 18 thing the other day, or was that you all see a lot of days?
Capital T.
Yeah, so
And then try it at 4,
yeah.
Capital T.
Well, for a lot of them, it was like in that situation. Most of them sell now.
the,
Well, that's still TSHOU 725,
Because
right?
of different chemicals and stuff.
what is, write it down for me, what it is.
TSHOU 725. And then try Capital T. Try 1, 2, well, try 4, 5, 6.
That's a little bit easier to control, but then you don't have to worry about trying to figure out what's mixed there.
I'll play with mine and see if I can remember what it is.
I was like, there's not, I actually,
So probably that unit was just a, you have to bring it out there.
Let me see what I can do. So you're not gonna be doing any space.
Yeah, I think the 100 ounce in there in general is. Well, I was gonna say, just our program was we haven't really changed our operation that much, and it was operation was rich for there.
Alright, so before we go into some of the mechanical side, I do want to kind of wrap back up with controls. Are there any issues in the field with controls that you see that we should talk about tomorrow? That you would like us to elaborate on? Are there certain things, certain instances, anything that you know of that is a common problem that you would like for us to cover? Yes.
Water source heat pumps, I started one up, and the water valve controller off to the left
Yes.
doesn't power up unless the compressor's on, and that's very aggravating when you're trying to test the valve.
So the reason we do that, and it's not just the compressor, we'll talk about it, the reversing valve has to be engaged also.
In cooling mode.
In cooling mode. So that the water source heat pump, those valves, they only operate in cooling mode only. I don't let those modulate at all in heating, because if you think about it, it's looking at liquid line pressure. When you're heating mode, your liquid line drops. It's gonna think, oh, I need to close those valves off. But that's not, you don't want it to do that in heating mode. So you can only test those valves when it's in cooling mode, or when the compressor's on and the reversing valve is engaged. We do know that's an issue.
You can't test it, so I guess if you go to cooling and it works, and, you don't trip on my head, then I guess it works.
Yes, you should not really have to touch that controller. We're gonna talk about it. There's a jumper on the back end
Which controller?
that I need you to verify.
The water valve controller? The back controller?
Yeah.
Last time I don't know if it was Jimmy or somebody, I changed like 6 points in that damn thing. Cause
They weren't set up.
yeah, cause it was causing the unit to trip out.
So Mike, they're mentioning, we just now been reported that the vector controller for water source heat pump was not programmed. So we've had the outside airflow monitoring from last class, and then this vector controller not being programmed. These side controllers aren't being done. What's our quality guy? Make sure he takes notes. Yes?
there any way to have like, so understanding the points list is a little confusing sometimes.
Yep.
Is there any way to have like a hierarchy of control or like a flow chart of what points have the higher control and what, if you don't have that in service, then it goes down to this?
So what he's asking for is a flow chart for the hierarchy of points, so you can, like a flow chart, a flow map of which points should be working and which would override the others. That's something we'll have to look at. That's something we may have to actually generate and think about, because that does make sense. It make it easier for you if you had a diagram where you can go through a flow chart to see what's taking precedence.
Yeah.
Right.
I think of the way to do that.
Yes.
This is some incremental, just overall noticing. Train's really pushing, at least in our local office, a standard point gauge. So if I got, 6 Intellipax, 4 Voyagers, 2 custom units, and 2 KCCs, I got, supply paid speed commands for everything, and then I got IBFD. And the customer's like, man, what is IBFD business? You know what I mean?
Right. You want us to match the SE key names.
Yeah, or even the TU key names.
Key names.
Yeah, 11.0 is gonna have
Oh, you
all the
already
key
know?
names, yeah.
Okay.
That's why I said it was an old version of 11.0 that you all had loaded, is because, one of the, a programmer for another office made the comment that that was a big problem, that he wanted to see key names the same, so it's been updated to that 11.0, so.
But we found out if we don't have the same key name, not only is it hard for your customer to know what, to map them, but to pull it into SC, SC won't pull in those commands unless they match some key name within it. So we're working on that also, so we know that's an issue.
Yeah, there's only a few exceptions. Some of the ones that, I've kept the names different on some of them. I can't think of any examples, but the ones that we don't want them to pull in and think that it controls the same as it does on other equipment, I kept it similar but different enough that it didn't automatically assume it and try to control the units to do different things.
Okay.
So for the most part, I changed probably 90% of the point names in the program. So.
But it's nice to know that you had the same feedback as what we heard from one other person that does a lot of controls in the last class. Because he told us he blows up a lot of our program and he wants to rewrite it to where it matches everything. So we take that into consideration. We can make that change for the new release.
Got one, the wild one space blackout.
Yes.
Just talking about that, why do you need it? I mean, it causes problems when the customer can look at the screen and see that it's involved.
So that's whenever typically it's in dehumidification mode and overshoots the space on the temperature. So I guess avoiding that would be helping get more reheat. But on the new, I think it's still on 8.2, but in 11.0 it's gone. So what it would do in the new program is that it should, for one, if it's going to dehumidification mode based on the space conditions, then it should come out of dehumidification mode and heat up the space if it actually needs to. So I think some of the changes we're making now is going to give the unit more reheat capacity, so that that's not actually a problem.
So on the application, I had that problem.
Yeah.
Basically,
It looked like it was way oversized for the space, there wasn't nothing in there. And Jimmy just told me to put it out of service.
Yeah, because it's more of like an informational alarm saying that we're in dehumidification mode and we overshot the space.
Right, I also have a question about circuit 1 digital scroll variable speed command overridden to 100%. A lot, I see that a lot. Why would that default to overridden?
So is it,
Just like on the one that I got here, that I uploaded from last night, the very first override is, that override is front panel, does not expire. I've seen this in TU on some of the ones that I've done, and I can't do anything with it. I can't stop it from being up there. It doesn't seem like it affects it.
so is it this right here where it shows like it has an alarms and the cooling? So,
I'm looking at it on the TD7.
TD7.
Yeah.
So it depends. I say if it's overridden from the factory, like if it's the operator that's overriding it and he's just doing it during testing, that's a relative. Like we could basically just, I think it just might be during testing, but there's also a chance that, so in 8.2, but even more so in 11.0, we have different TGPs, different programs that are running at different levels. And I think what you might be seeing is that certain parts of the program are overriding it at like a different level of priority than level 9, and it's showing up as an override. So it's not something that can be released, it's something the program just controls to. I think you might actually see more of that in the future, where the program's writing to it.
So does it mean, when I look at it here, I look at it on, Edison, we were talking about a while ago, it's got it up there as well, so all the time, I can't ever get it to go away. And it does read, so does that mean that is a true 100% command on that digital control?
So the override that you're seeing on there?
Yeah.
So that's what the program's controlling to. If it's not like an operator level, like if it's, you said you can't release it?
Yeah, this one here says, front panel, it's controlled by front panel -8.
Okay, so that is,
So that'd be from our testers. What's happening there is when we're going through testing, when they're doing cooling, our testers override it to 100% and then turn compressor on so it's full capacity. Then what they're doing is they're turning it off. They're turning the compressor off, it shuts it down, and they don't go back and think about releasing that override.
So how do I get rid of it?
You just, so if we, you wanna go show them how to get rid of that real quick?
yeah.
I tried to release it and it comes right back.
From the,
And going back to this Y1 space lockout, pretty much if my space temperature drops below 3 degrees from set point, you cut the compressor off, just so we don't overcool space. But moving forward, if our space temperature starts to drop, we drop our evaporator, and then our DA will go up, our discharge temperature will go up, because we're getting more reheat capacity. So we're trying to prevent overcooling space by dropping our off coil temperature, but it gives us more reheat capacity out the unit itself. So moving on to for the next couple hours, we'll start talking about the startup. As you can see, the first thing we mentioned is test and balance. Test and balance should probably be performed first before you do a true startup. There's just so many things that can change based on the outside air. It changes your refrigeration, your minimum delta T across the heater, all those things. So I know that's not always going to be the case, but test and balance is probably first and foremost for our units. It's not 100% outside air. If you have mixed air applications, you really want to get that done first. Then we'll go to identifying options and factory installed components, VFD adjustments, fan proving setup, cooling startup, heating setup, and field pressure control. And then we'll talk about alarms and troubleshooting and everything. So the first thing is when we start a unit is our phase monitor. How many of you have dealt with the IFC 450, the 455, the PISA? Yeah, that one. It caused a lot of nuisance trips, right? It was a huge issue. Very sensitive. So the IFC 450 to 455, it was an averaging phase monitor. It did not read real time. That's where our issue came into play. So you would have nuisance trips with the IFC 450, IFC 455 because it averaged voltage over time and it didn't correct itself. And we finally realized that the biggest trip was a phase unbalance at 2%. Well, when we finally realized that was an issue, we switched to the time mark. The time mark reads true, is real time. So it's actually monitoring voltage real time, and it's taking away a lot of nuisance trips.
But you could adjust the old one though.
You could. The problem is the old one adjusting up. The 2% is there for a reason. It's not because of we look at compressors or the supply fan or exhaust fan. It's because of the condenser fans. The condenser fans are 3-phase. They're not built very well. We had a job in Massachusetts where the phase imbalance is around 4 or 5%. It was on a Plymouth, so they were pushing 500 something volts to that unit. Huge phase imbalance. We lost 29 condenser motors in about a month period. Wow. That is because every percent above 2% increases the motor windings by 14 or 15%.
Oh wow.
It's a squared increase, and so for the temperature increase in the windings, it's 2 times the square of the phase unbalance. So if you have a 2% phase unbalance, that's squared as 4 is 8% increase in motor temperature. But if you have a 5% phase unbalance, then that's a 50% increase in motor temperature. So that's the reason why just a little bit of a phase unbalance difference can make a big difference in temperature winding. And I think a more fair way to say it would be that the condenser fan motors are a lot more, they're not as well suited to take a higher phase unbalance. So when you should get up to the 3, 4, 5%, the condenser fan motors were failing because of that, versus the compressors, they're more durable and they could take a 30 or 40, 50% increase in motor temperature
and because of that load, the electrical load, it was actually there on Plymouth, they were just pushing all the power there with no return line back. So they were just killing me. They would see 510, 512 volts, and one leg would drop to 460. So, you know, we were seeing, yeah. And so we put the phase monitor in to protect it. We realized, but the IMC became it caused too many nuisance trips. So going to the new one, the time mark that you see here, it doesn't have the digital display, but it's a lot better. It's going to help. Yes.
So you're okay with 480 and 2%
Yes.
balance?
Yes. We'll let you go to 3 if you need it. But we set it here at 2. And just so you know, even here we have problems with 2% with our factory power. We saw it this weekend. But 3% is what we'll allow you to go to. Anything outside of that, give us a call. The phase monitor looks at 10% over voltage, 10% under voltage, phase imbalance, phase loss, and phase reversal. That again powers the relays, the ESR 1, 2, and 3. If those are lit, that means you're good to go. The unit is good on phase monitor. Or safety device, which is your smoke detector. You don't have a trip on your VFD, and missing one. Freestat, thank you. Yeah, we go over that a little later. Freestat.
Somebody's looking ahead.
No, I had it happen just.
No, okay.
Was the Freestat in the wrong location also?
No, it was the right
Oh, that's
location.
good.
Yeah.
Were you the one with the button that didn't?
Yeah. No, that wasn't me. That was.
No.
So we've had issues with our Freestat also, which we'll go over, because we had to put it in the wrong location and they're hard to service in some applications. With the phase monitor, we've actually included the LED status, so it's just a way to blink. Again, this doesn't have a readout like the IMC 450 or 455, but it is a better monitor in general. And our complaints have dropped by 95% by going to this monitor. So if you have an IMC 450 or 455 in the field that's causing you problems, give us a call, we'll switch this out for you. Because you're going to keep having nuisance trips, and their displays fail fairly regularly too, just because of hot heat. So for test and balance, the points that you need to look at are duct static pressure set point, your minimum OA damper position, maximum OA damper position, supply airflow set point, exhaust airflow set point, IVFD signal, powered exhaust VFD settings. The supply airflow set point, again, can be found on this middle page at the very top where it says supply airflow. And then the powered exhaust can also be found on the powered exhaust fan curve. If you look on the back of one of these, you can find them on this middle there. Minimum OA damp position. Again, remember, if the unit has 50% outside air, 50% return, your minimum OA position will be around 10 or 15%. I'd be highly suspect if that was set to 20, 25%, it was actually balanced correctly. I have not seen it yet. That's not saying it won't happen. I haven't seen it yet in the field. 10 or 15% is what we typically see. 50% outside air, 50% return.
That 50/50 in the middle?
Yes. So if you look at the submittal itself, again, on this page, on the front page, you'll see supply airflow and then outdoor airflow. They should match if it's 100%. If it doesn't match, you divide by the 2 to figure out what you're getting. So for right now, my supply airflow says 9,000. I'm looking at the ME Stoughton High School one. It says my supply airflow is 9,000 CFM and my outside airflow is 4,425. That's equivalent to about 50%. I would expect to see that minimum OA position of around 15% or less. 10 to 15% is what I would be looking for.
It'll be one or the other.
I'm sorry?
It'll be 100% or 50%.
Or even smaller. So when you start even going to 20% airflow, you're going to crank that damper down even more. You could be down around 5%. So if it's a 20% outside air, 80% return, 5% is what we typically see at that point. In some cases, we actually screw in some of the dampers, and there's probably like 8 blades. 6 of those blades we screw down, and only 2 of them will actuate. We'll try to block off some of that damper in those applications. The more return static you have, the worse it gets. Less return static, the damper is a little more forgiving. So identifying the airflow monitoring. You'll see here Magnuson gauges on the left, green straws on the right. as well as the outside airflow probe. How many people have had issues with the outside airflow monitoring? Or not being set up in the field, or not being set up in the factory? Right, so there's three more with the outside airflow not being set. We heard about it last class, and we're trying to mention of it, that it's all happening around the country. So those that should be set in the factory. Give us a call, we can get you the right, call us, we'll help you set it back up.
I've seen several units with the dudes on the left of the tubes are flip-flop.
So that is another one issue we're having. So to determine, so upon startup, you want to identify your supply fan and your exhaust fan. Turn the supply fan on first, pull the exhaust fan tubes. You should be reading positive on the supply fan. If you're not, you know that they're flip-flopped.
Well, just to clarify, so when you say flip-flop, do you mean the supply has to switch with the exhaust, or on that, just on that, like, so for the supply, the positive and negative be switched?
Both
That
times,
wiring.
the DAS guy called up before me, so I don't remember exactly. I wanna say it was, for one, it was just flipped there, the other one was flipped on another. It wasn't both on one unit.
Okay.
I don't know if it left or right, but on one, it was on the same one was flip-flop, and on the other one, it was flip-flop on the other. They wasn't between each other.
Okay, so, yeah, it's a little better.
So I will say, so like, if it's, like, if the positive and negative is flipped, it just shows UL on the actual, sensor, so it doesn't go into the negative, so it wouldn't read backwards. We have had some too before, like the supply, one of the supply positive, we switched with the exhaust positive, that when they ran the tubing to the back, that it's going to the wrong spot. We're working on getting color tubing to replace that, so that, for the components, you can, visually see that if you go to the exhaust and it's got one blue and one red, they went the wrong color. Yeah, it's still translucent.
Okay.
Yeah. So those are things we are working on as continuous improvement, because they've been reported more and more in the field. Especially the more units we push out the door, the less it's getting caught. So now we're trying to give visual cues to our testers, because again, they're the last line of defense. They're starting these units up every 2 or 3 hours to try to get these out the door. So we're trying to make it as easy as possible on those guys.
That's something we should look forward to starting? Yes.
Yes. I agree with him, yes. Because it does happen. Frequently.
So these do all get run here before they go.
They get a full run test here, yes. Now, is it 100% thorough? I can't guarantee that. We try.
I think there's a lot of things that can be missed, especially like if you think about if they're running the supply fan and exhaust fan at the same time, they can probably look at the PAs over. They don't know if the airflow's right or not, so they can look on there and it's reading correctly, and then they send it out in the field. But you all test it with just the supply fan, then you can see, oh, something's not right here. And they may also, and we're working on a little bit more on standardized instructions to make it define exactly how they need to go through these different testing setups, because there's a lot of, our testers are, I think they're pretty good, but there's things that you kind of learn over time that maybe we didn't even think about, and it needs to be put into standard instructions on testing the units.
Especially on Friday, 3 o'clock, right?
Yeah. Well, so like just for example, if I want to test the exhaust fan with the exhaust fan actuators on it, first thing I do is I go to TD7, override exhaust fan on, override exhaust fan dampers on. Well, those can get flip-flopped here at the factory, and you'd never catch it unless you did one at a time. But if you're trying to test everything real quick, you override those both on, it gets to the field, and when the program's trying to control it, it doesn't work properly. So it's those type of things where we're trying to break down the sequence for the testers to know, do step by step. And when we see them in the testing, we know what's going on. And that kind of falls on us too, because we update all the programming and do all the wiring diagrams. We haven't given our testers proper information, just like we're not great at updating the IOMs. So we're trying to give you guys as much information as possible.
I'm sorry, I got a bunch, I'm sorry. So, I had a bunch of times, or I'd say several times the last 6 to 9 months, where I call a tech report on something, they'll say, oh, go to line, blah, 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 on the schematic, and that sticker's not there. That portion of the schematic is, I don't see it, it's not here.
So that's their schematics are not on the doors.
Is it part of it missing, or is just
The whole sticker, it might go from like line 24 to 99, and now it's just gone.
I was missing one of the diagrams. So
It's missing one of the pages. Mike, it's not like you printed it out wrong. It's that if you have 3 diagrams, they put 2 of the 3 on.
Yeah, it might go from 1 to 200, and the last one that shows the last 60 or whatever is not there.
unit.
Every single one of our units now should have 3 wiring diagrams. Just that third page may just be pretty much empty, just have the legend on there. But it should always have 3 pages. Now, you did look at the other door right next to it, because that sometimes they can't fit them all on the same door. They might put
So
them on
that's
2
good.
different doors.
But that's a good point, is that every unit should have 3 diagrams now, no matter what. You'll always have 3 wiring diagrams. If you don't have those, you're missing something. So you may be accustomed to 2 diagrams, everyone has 3. Even if it's a small unit, just because one option may be put on a 3rd page, the way we have it set up. Yes.
So if we find that there's only 2, do you want us to call in and let you know?
Call us, let us know. It's 1 that we can get you the 3rd, whatever page it is, and then 2, we can go back to who finished, who's the closer on that unit. Our testers don't put those on, that goes to a closing group.
I actually think I had one of the prints were, outside, basic, little hard to troubleshoot.
Yeah, but it does. So again, any of those type of issues you find, let us know, because we,
And on your head.
you know, the more reports we get back, the better we can let quality know and talk to the guys on the floor. You know, if you guys are just fixing the field, we don't, it's hard for us to make changes.
Are you planning on getting any kind of field quality alert forms online or on the web like Train has?
So we're gonna talk to you guys, this presentation's got field quality alerts in it. So as we send new documentation, you're gonna be, your email address, anything that we find that's a field quality alert, we're gonna email you.
So this is field quality alerts that you all fill out that comes back to the factory. Is that what you're talking about?
Yep.
Yeah.
Oh, those are different. We don't know how those work. We don't know how those work. They go into a black hole, they never come out when you fill them out.
Fill the XIL or
They'll email you and tell you they got them.
Yeah.
That's it.
And I don't think those always, just like how the startup reports don't get sent to us, the field quality alerts don't get sent to us either. I can think of 4 or 5 only. Mike, unless you,
So,
We don't see a lot of them. Did Jeff talk to you all about the XOI system? No, don't see a lot of kids on it, so. Yeah, so I know that Train is sort of piloting it in some offices. Our understanding is they're kind of making a renewed push to get it out there. I can tell you all that from our perspective, I mean, that is a game changer, it really is, because we can see those videos to, really understand the problem you're having. I was showing our sub-assembly supervisor yesterday, so his area is the ones that put the gasket around the doors. They also put those schematics on that y'all are talking about. Just yesterday, I was able to show him a video showing the problem with the gasket around the door. It really helped him understand the issue.
which, by the way, he's talking about a reporting thing for Train to be able to post pictures and videos. It's reporting for Train quality issues. So it's not just like filling out a form that's text. They can put pictures in videos and fill things out. So.
But as far as quality alerts go, Chris, do we,
So we do out field service quality report on a comfort site, and I don't think where it goes, it doesn't even list you guys.
it doesn't, we are not in comfort site. Chris, you've gotten a few field quality reports, but how do we get those?
They come in right now, through Sean McCormick, who's the, advanced quality planning leader at Train. But it's very, I'll say lengthy process.
So,
There's no direct route in KCC for any field quality alerts you guys.
We just emailed Jimmy, Sean.
we'll pass it along to them, yes. So, I mean, out of curiosity, how many field quality, who has filled out a field quality alert for Horizon?
I didn't know one to either.
So you guys can't really, because it's not comfort site. It's not comfort site, right? Is that how you do it?
Yeah.
So, yeah, we can't even get them.
They done emails back and forth. Couldn't you guys maybe just create an email address, fieldqa@kcc.com?
So where you're asking us to send these startup reports to that email.
If you do
Could you
that-
send them to that email?
I would put it, I actually think it's probably the best idea, send that to the same email, but in the subject, put field quality alert.
Yeah.
Everybody, there's gonna be multiple people on that list that sees this, not just me, production, Jeff Siegel, they're all gonna see these startup logs. So if you have a field quality alert, use that at Horizon Startup, at KCC MFG, send that. Or if you have any issues, you wanna send it to email address, because that won't just get lost with Jimmy. That gets multiple eyes could be looking at it.
If we're sending the startup bulbs there anyways, and you're doing the startup and you see it, I mean, it's not gonna take a snapshot and shoot it to the same email.
Yeah, it's gonna take about 10, there's at least 10 people on that list right now. So there's gonna be multiple people seeing it, from production to us to quality.
And you want an XOI video sent there as well?
Well, like I said, the XOI is in pilot, current pilot stage right now, so.
We've been doing it for several years, we've been doing it,
Yeah, so the last week, we just had a handful of people that looked at it, but, I believe we have access now, so if you put them in there, we can see them. But also,
yeah, it's just a link to a webpage, and you can just pull it out, anybody can look at it.
So, yeah, the trick with XOI is Train has to send us the links to it. If we don't get the links, we can't get it.
No, I can email it right from my iPad. Yeah, we can email it to you.
Sure, yeah, sorry, what I meant to say is that we, ACC, cannot go into Train's XOI account and search for issues that are related to Verizon. Somebody from Train, a technician or management, has to send us a link.
So if we do a field body alert, if whoever's got capability of doing it, so I can just add that video as a link to that same email.
Yeah, absolutely. So the video I was talking about that I was looking at with the supervisor yesterday, someone in the field sent us a link and it went straight to XOI, we were able to do it on the laptop. So that, also anytime you're on the phone tech support, if they actually send me a photo or a video, I'm in the same office with these guys, so they will, if not call me over to their desk and show it to me, they immediately forward it to me, and we can, so I see that stuff almost right away.
And getting it to us quickly also does help too, because we're right next to the testing, we're right next to the assembly plant out there. And if something comes up that we think might become like a reoccurring issue, that like it's pretty frequently that somebody will send us something and we go, oh crap, and then we walk out there, walk straight to the production line and start taking a look at units. So it's something, it's an immediate response, even if we're not fixing it right away, that if it allows us to immediately get on it and start taking a look at it, especially if it's something that we think might be reoccurring. We can get to it more quickly versus if it gets reported and then it has to go through Train and all the management side, it's taking a long way around versus if it's going to one of us or it's going to that Horizon startup email in the startup document, it can get addressed more quickly.
So moving forward, the supply fan piezo should be labeled SPZ. Exhaust fan piezo is labeled EPZ, and the green trellis is self-explanatory, its own little readout. So when you first get to a unit, first thing we do, if it's got a piezo ring, pull the tubes off of the piezo. Or first, pull the tubes off the piezo itself, and then press the left hand button. You'll hold it until you read 0, 0 on the piezo ring. Then it zeroes it out. From there, you'll actually go into TU. If you read anything above 0 for your supply fan pressure local, you have to calibrate that. You'll right click, hit the figure, and then you'll do a calibration offset. If I'm reading 0.18, you do negative 0.18. If I'm reading negative 0.18 of the left hand, you do positive 0.18. You're just offsetting what this controller's reading. Typically, what's happening is the voltages within the unit, if they're high or low, can cause the inputs to fluctuate some, where you're not getting a true 0. Knowing if it's a two-position damper or modulating damper, if you look at the actuator itself, the last part should be -S for two-position, and then it's -R-S for modulating. Again, if you've got modulating dampers, you need to set the min and max values of the as a set point within the unit, and that should be done during test and balance.
Is there any plan to secure those outdoor dampers better? They pull themselves right off the bracket.
Yeah. So Chris, what he's asking about is the mounting bracket for the actuator, and our plan to fix that, or to correct that.
Yeah, and that's one that we needed to, we need to change our mounting process. So when we mount that, right when we mount it really narrow, it tends to get in the way of the dampers. So we need to change it so that it's wider base, and that makes it more stable, and has less.
So you're probably seeing the mounting, it's probably doing something like this, whereas the extender is actually nice and long. We're trying to make it more of a hat when we make the mount. Because what's happening is when this,
So just to clarify a little bit,
Yeah, you
let me
can
argue
clarify.
that basically, but where it gets mounted, so the actuator's right here, this is the pin that holds it in, and this is where it's being screwed into the sheet metal here. So the issue we're seeing is that they were extending it out, and it's just, you know, the torque of the damper, it just twists this, and it can just pop out because it has a lot of pain. So I think we're moving to get the actuators mounted like this. Part of what caused this is there was a creep over time to go to this, because this is easy to install on the manufacturing side because you can just pop it into place, and then so over time it's kind of transformed into that versus this being a little more difficult. But that's essentially the direction of trying to get the actuators mounted.
yeah, this happened over time and it got worse until it got reported to us in the field. And then we found out this is what was happening in the plant. And we're trying to revert back to more of a secure mount, so that the actuator is not torquing itself and popping off the shaft. Here is the Mitsubishi drive and the display itself. You have your run light. If the run light is lit, the motor is running. MON is the display in the monitoring screen. PRM is the parameter adjustment screen. PU, if it's lit, means the VFD operation is in hand mode. And then VFD operation, externally controlled, is EXT. It's pretty self-explanatory. I'm sure everyone's touched the Mitsubishi VFD. Has been starting those up. We are moving the TR150s in the future as standard. We have had some issues with the TRs in our cabinets overheating, which is why I was kind of surprised about the liquid the Mitsubishi. We haven't seen that. Hasn't been as big of a problem, but we've had problems with the power card with TR50 going bad, which we're addressing. So with the Mitsubishi drive, this is just a quick step how-to adjust the parameters. You press mode to eliminate the PRM LED. Use the rotary dial to the right, which goes from parameter 0 up to parameter 800 something. To adjust parameters and for them to take, you have to set parameter 77 to 2. So you rotate the dial to 77, hit set, it'll show you the value. Change it to 2, hit set, it should blink, it should flash. If it does not flash, that means the parameter did not take. And then you'll just change your parameters in general. The only two you should really change is parameter 1 and 125, the max hertz for VFD adjustment or airflow. Any of the other ones are their factory default. The ones we have seen, if our unit is feeding another unit and it's off, it could actually cause the supply fan. Let's say it's feeding a big climate changer and the climate changer is running. If my fan is running with it, it causes a buildup of electricity. So when it tries to start, it can cause a overcurrent, I believe. Overcurrent. Yeah, an overcurrent. So we do a flying break. Give us a call on that one. It should be set, but that's the only time that we should really ever change parameters besides 1 and 125. And then the TR150, these are the parameters themselves that we change. The big thing we want to let you guys know of, the two in red, there's probably 300 units in the field with the wrong parameters set.
I was gonna ask that.
Yeah.
Because I've had a shit ton of those that you go to the site and every time the customer powers the unit on off, the drives will not reset.
Correct.
And I've had to go in and change that parameter 1420. Some of them I found are set on 5 trips.
Yeah.
Most of them are 3 or 5.
Yeah.
Yeah, so
Dan Boss, when you call them, they don't recommend that you change that thing to infinite.
We even work with Dan Foss, but we're infinite is what we can do.
Well, I've put a bunch of them to infinite,
Yeah.
but when you call Dan Foss, because that's who makes strain drives, and you say, well, they go, well, we don't recommend you do that, but you can.
They don't understand that ours are, because this unit's 100% outside air,
Yep.
we have to shut that unit down immediately
Yep.
because of code. So if there's a fire, that's units, we gotta hard stop this thing immediately.
Yep.
If not, I'm dumping in outside air and I'm feeding the fire. So we have a special exemption for why that's happening.
So I have changed the ship ton of them to infinite.
Yeah, they're infinite.
It is worth noting so that those two parameters, it's not like a risk to the equipment or any of the safety or anything like that. It's just switches it from manual reset to auto reset whenever the unit goes into alarm. So like, our e-stop is auto reset, but if the unit goes into e-stop and these parameters aren't set, then the VFD is actually manual reset, so they'll have to come up and reset the unit. So it's not as if the equipment's gonna become damaged, it's just that it's manual instead of auto.
Basically, if they go cycle power, it's not gonna run. If you don't change these parameters, or if you have a smoke detector or anything,
Won't come back on at all.
it's another service call. And again, there's probably 200 to 300 of these in the field. And they will be on model numbers that have OADG or OANG. If the model number starts with OADG or OANG, they will have the TR150s. It's only our Rev 6 model numbers.
So if we get new drives from you, they should be pre-programmed, right?
They should, yes. They should be pre-programmed by us in Texas.
Those species I was getting, like out of the 6 I'd done, a couple of them came back and they were not programmed. So I was having suggestion they put like a sticker on there, pre-programmed or something.
They want to supply that, but I do that. It's nice to know 2.5.
Our practice is the pre-program, but we need to have a second check in place, I guess, or at least a sticker.
Well, it sounds like I feel like there's a lot of separation between the people who ship our parts and tech support, so.
I'm sorry, they drop shipped it from somewhere, that's what it was.
Oh,
Okay, so then in that case, it wouldn't come pre-programmed.
Your defense,
yeah, if it comes from us, we program the
I
drives.
started running it and I could tell right away something was not right. It would've been nice to know.
Yeah, our drives and the UC 600 we program. So if you have a UC that cracks out, we put the backup in that we have latest on file and ship it to you.
With that, it's also worth noting, I know you made a comment about the custom programs earlier. If custom program, like if the programs change from the factory, and you all do that without calling us, we would actually prefer that you all send us the program and we'll keep it on file. So that way, if we get a warranty replacement for the UC, we can load that correct backup back in there before we ship it out.
3 years down the road, contractor calls us saying, hey, we need a UC, we don't have the right one that's been changed. It could cause issues in the field and cause a return trip or things of that nature. So yeah, if there's any custom program done, we'd like to have that back, just for us to keep on file. So going back to the submittal page itself, on the supply fan, we put it on an operating RPM and a minimum RPM. The operating RPM corresponds to what we set as the max hertz. We offer 2 types of motors. Motors that have a nameplate of 1745 RPM, and the other one at 3450 RPM. And what we've done is if my operating RPM says 2045 and my nameplate's 1750, your hertz, max hertz should be around 68. And then the min will be around 36 to 38 hertz. The min cannot be changed without contacting the factory. If you need to bump up airflow, you can change the maximum RPM, that's perfectly fine, but the minimum have to be contacted. And then for the nameplate, if you have a supply fan with a 3450 RPM motor, the max hertz is 46. You cannot go over that. Reason being, you have now created a safety situation for the unit itself. If you go above 46 hertz, we use class 2 wheels. They are only rated to around 2700 RPM. Even if the motor can handle taking up to 960 hertz, now that fan can fall apart on you. It is on the plenum fan. They are class 2, so you can only go to 2750.
Why don't they put that information on the data tag like Train does? Because train on the data tag, any unit that comes with a plenum fan, if they want to take it over 60 hertz, even the motor data tag says 60 hertz, it says right on the door tag in the fan compartment for a climate changer, it'll tell you that you can take this fan to 68 hertz or 72 hertz, but it's on the data tag of the unit.
I think,
as in on like the outside, like the ETL label or the
Yeah, it's on the build tag of the unit.
So that's some of the
Because when we
line.
started going to the platinum fans, now the 60 hertz isn't irrelevant.
Right.
We're worried about the air changer or the air balancer, making air balance, so we're gonna take that fan up to 65, 68 hertz.
Yep.
They actually have a test piece of paper with all their data, on the motor and their, fan curve and all that, RPMs and everything, they take that to all the motors,
Yeah.
all the fan motors.
But it is on the sticker on the door from that fan compartment, so that we know, as soon as you walk up, it's a quick reference. It's like, oh, okay.
So, just for, the chances of us getting that changed quickly
Oh,
is very
yeah.
rare. The reason why is that label goes through a process outside of us, which is ETL or UL.
Yeah.
We have to open that file. That's 6 months for us to change.
Yeah.
But at least you do know that for right now, don't go above 46 on that one. And again, you should only see that on 15 horsepower motors. It'll be a dual fan, or it'll be a single fan 15 horse, or dual fan 15 horse. You'll see that motor. That's the most common. And even then, it's rare, but we want to give you the information.
So you guys don't make a high static setup?
We do have high static, but we typically don't do high static with a 3400 RPM, 3450 RPM motor. Those will be typically the 1800, but we use a 25-inch wheel, or dual 25-inch.
Okay, I walked up on something that was damn near 100, you know what I mean, before.
Yeah, those we're over speeding those fans like crazy. Technically, the 1750 RPM motor can go to 120 hertz.
Okay.
They have the same bearings as the 3450. So they're built the same, just the poles are different. So you can technically take that up to 120 hertz if you don't overamp. So 100 hertz it's not unheard of. It's
Okay.
just- we shouldn't be running there unless there's an issue of airflow, restriction of ductwork.
Okay.
It's not designed for that, but it can handle it. So here's something else that we try to set at the factory, but we can't do, and we don't mention in the IOM. It's setting the indoor fan failure switch. Our fan failure switch is a interlock, mechanical or electrical interlock and everything else. If it's not made, we cut off the commons to all your compressors, heat, everything. It has to be lit, which is your IFFR relay. So what we're asking for on startup is if you have a VFD fan, override your VFD command to 0. Take it to minimum hertz. If it's an ECM motor, take it to 50%. At that point, I want to take my indoor fan switch, turn it clockwise until the IFFR relay is not lit. Once it's not lit, I then want to go counterclockwise 1/2 turn or a half turn, and then it should energize at that point. That to us tells us that is the minimum airflow, you've set it correctly, and it's the minimum airflow for the ductwork's going to see. So we can set it here, but we don't have our unit set up with ductwork and static pressure. So it's not set properly.
With clean filters.
With clean filters, yeah, things of that nature, right? And even then, sometimes we may not be doing it with the filters installed.
Well, you get out to a site that's been under construction, you open the door, you look at the filters, you go, oh, shit, man.
So, yeah, we're asking for this because we've had a lot of nuisance trips with getting fan failures. So this will prevent that in the future also, and having return calls.
ECM fans are 50, ECM.
Yeah. The ECM is 50, and anything with the VFD that has a Mitsubishi or a TR150 in it, it goes to 0. Now, when you set a 0% signal to it, the drive's programmed for minimum hertz. So it'll go to its minimum, it won't go below. Next is identifying the compressor styles we have. We offer fixed speed, digital, and variable speed. They're very identifiable by the model number. If it's ZP and then numbers, it is a fixed speed compressor. If it is ZPD, the numbers, it's digital. And then ZPV and the numbers is a variable speed. The fixed speed and digital can be on both circuits. Variable speed is only on the first circuit. We have not put it on the second circuit and don't have plans to as of right now either. So for the startup, here's where it's going to vary on everybody. Again, with Train pushing the new 45 is the new 55, and with the cold temperatures we're trying to do off the evaporator and the amount of reheat we're needing, we have to change our charge. We're needing a lot more refrigerant for it to balance this system. So what we're asking for is to turn compressor 1 on. If it's a tandem, you turn both compressors on. If you have a digital scroll compressor, you'll change its analog value or analog output to 100%, and then you override the hot gas reheat to 25%. Typically, we've said hot gas reheat at 0. We're now asking for it to be 25%. We're trying to fill that receiver and the coil with more refrigerant that's going to be needed during part loads. Once you have it, all that set, you let everything adjust for a while. We're looking for subcooling to be between 10 and 15 degrees. Superheat is 15 to 20. And then the other critical one that typically is not asked for is the compressor superheat or discharge superheat. We want to see that around 40 to 60 degrees. It's something that's not commonly asked for, but we are asking for it. Again, from there you can adjust charge if you need more refrigerant, less refrigerant. And then once you've done that, you want to override the hot gas reheat command to 100 to make sure you get full flow to the hot gas reheat. It should be the same temperature as the outlet of the compressor. Once you've done that, override those compressors off, repeat for circuit 2. This is just a quick diagram. If the unit's installed with just fixed speed compressors, we put an APR valve on it. So everybody know what APR valve does? It's pretty much a glorified hot gas bypass. We just keep it on to maintain 108 PSI on the suction, or 38 saturated.
Suction pressure regulator.
Suction pressure regulator. The reason for it, since this unit's 100% outside air with a fixed speed compressor, if it's 60 degrees outside, if I don't have capacity control, I'm going to drive my temperature into the low 30s. At least with the APR, I keep the evaporator cold, keep the compressor on, keep dehumidifying, and then try to reheat as much as possible. We are pushing away from the APR.
I was gonna say, are you all setting those up properly from the factory?
They should be, yes. Right, and so that's a good point that I didn't actually put on here. When you're looking at the APR, the superheat, if you're taking the superheat at the compressor, it's going to measure 20 degrees because that's what the APR is set for. But then you want to measure the superheat at the evaporator. If the evaporator superheat is higher than the compressor or the APR superheat, that'll kill the compressor. So if I'm taking my suction temperature at the evaporator and my superheat calculates to be 25 degrees, and I take my suction temperature at the compressor, and it's 20 degrees superheat, you'll kill the compressor. The superheats, they'll fight each other. They're going to fight. Yeah, and one other thing that we also point out is that the reheat valve is at 100% when the compressor's off. We always get asked why is my reheat at 100 when I'm in heating mode, or we do that just for liquid migration and for refrigeration balance. Reheat valve at 100, it's collecting liquid for us.
But you also do it during heating.
For heat pump mode, yes, we keep our reheat valve at 100% just because that's another condenser.
Yeah.
That's just another way for us to reject heat and get more capacity out of the unit itself. Then the heat pumps themselves, pretty much the same thing. So our older units that I really wanted to look at real quick, and heat pumps, you had to have more, or air source heat pump, we had to have more refrigerant in heating mode than we did in cooling mode. And cooling mode required less refrigerant, so we had to install a charge compensator. Has anybody heard of charge compensator for heat pumps? Yeah, gotcha. Or yeah, gotcha. Basically, it's a mechanical device that we use. In cooling mode, if this is my discharge line, this is a vessel. It's a shell and tube heat exchanger for the most part. If I'm in cooling mode, this pipe gets hot, causes this vessel to heat up, and then pushes any liquid that it holds into the liquid line. When I go to heating mode, this now becomes my suction line. So if I'm in reverse flow, this pipe gets cold, liquid goes to the coldest point of, or goes to the coldest place, then my little tap pulls liquid out of the liquid line and stores in this vessel. So that's how we pull refrigerant out. It's about 4 pounds difference. So in heating mode, I put 4 pounds into the charge compensator. When I go into cooling mode, it pushes itself back out to the liquid line. Moving forward, we're using a biflow liquid line receiver. So the receiver can, I'm sure most of you know what liquid line receivers are, with the tubes where one's higher than the other. So typical liquid line receivers,
Give it time to boil off.
yeah. So typical liquid line receivers, liquid comes in here, and then you pull from the bottom because that's where all your liquid is. What we switched to is a biflow. So my tubes do this. So you're always pulling from the bottom and dumping in the bottom. So now I've got a receiver that no matter where liquid comes in or goes out, it's always pulling from the bottom itself. And our liquid line receivers are holding up about 10 pounds of refrigerant. Going into water source heat pump, as I mentioned before, there is a external controller on the water source heat pump called the vector. It will be powered only when a compressor is on and the reversing valve is energized. It's only used for cooling mode. Basically, it's looking at my liquid line pressure and modulating the water valves just to maintain head pressure around 400 psi. The one thing we've noticed and seen in the field is the jumpers on the back are not set correctly. So we've given you a picture of what those jumpers should look like when you have a water source heat pump. Then this is a operating area for our compressor. It tells you you're good during startup. The bottom is my saturated suction temp. The top, and then the vertical axis is my condensing saturated temperature. So basically, if you're looking at your pressure gauges and I'm running at saturated temperature of 40 degrees and my condensing temperature is around 120, you know you're in a safe zone. If you're outside of that gray area, let's assume you're reading on your gauges around 30 degrees for your suction, for your saturated suction, and that's 100 psi. My suction is 100 psi, but I have a head pressure of 140 for my condensing temp, or 550 psi, I'm outside that map. I'm outside that range. And there's an issue. Restriction, something's going on. So this is just a quick chart that if you look at your gauges, get your temperature based on the pressures, put it on here, you should be in that area. If you're not, there's a problem. Is there any questions on this? Or what was your issue with them? They liquid line transducers leaking. The O-ring, or was it
The body, like, what goes up in the transducer itself.
I have one with the O-ring leaking.
Yeah, we've been, and we covered a little bit here, a little bit, but you are talking about, is it liquid line transducers?
Yeah.
Yeah, we've been working with the supplier on getting one that goes directly onto the fitting instead of having that piece that goes in the middle. So yeah, it's we just approved it last week and they're making them now. So we have should be getting them in house in the next couple of weeks, 2-3 weeks, and then we'll be using them then. So.
I got one on the 80-ton cabinet.
Yep.
We get those liquid line transducers put down in the main electrical cabinet, stuff in that top panel where nothing else, and you gotta get it at the time to get to it. You know, the liquid line comes through there, and then now there's stuff through the bottom of the panel, and then you got your transducer right there. How come we just can't move the 6 inches down to the lower panel?
Same way with are the pressure taps up there too? The pressure tester up there.
The what now?
The service ports.
Yeah, I think there is probably a surf board up there. Can we just move it all, just so we don't have to open another panel? That 80 ton I got is 4 foot off the roof, and then I still got the unit, you know, it'll.
It's 8 feet above that to where you
Yeah.
get to.
It's pretty tough.
Yeah. That's a big change, but well, we'll see what we can do on that. I'll get engineering involved. That's,
Yeah, well, this is one of the ones that's gonna send to Chris Wasabi. I think a general change that we should be looking at is all the service ports throughout the unit, trying to move them as low as possible on that particular line. Because I know in some of our cabinets, like the OE and the 5 cabinets, for the circuit 1, it's behind the compressors back there, and so you have to, in order to get the,
Pardon my hand every time.
yeah, I burn my, yeah. About every other job site, I burn myself. I think I learned by now.
so, I mean, that's an easy indicator that something maybe we can fix.
Yeah. Especially like for tandem sets, see, it's hard to get near those tabs.
So,
Okay.
so even on top of just the OE and Rev 6, just in general, trying to move the taps to more accessible locations.
And this is just a quick chart for water source heat pump. Last week, it was brought to our attention that the pressure ports we use to measure pressure drop across the supply and return. You guys wanted to use what was it? Instead of using the pressure gauges, we're going to flip to.
Can't remember what it's called.
PT plug?
Yeah.
Yeah, we're going to be switching to those
Yeah.
very shortly also, to get rid of measuring based off the pressure gauges and using those taps themselves. So basically this chart here just tells you the PSI drop that you need based on the model, that you have the proper water flow. So that should help you. Subcooling and superheat are the same for cooling mode for DX, just as DX. Heating mode, your subcooling could drop about 5 to 10 degrees instead of about 10 to 15. Just something to be aware of. And then just for flow diagram, our water valves are normally open, fail open. So if I lose power to those valves, they automatically open, so there's full water flow, but not restricted. There's spring return also. Sometimes if they lose power, they are a spring return open. And again, they're only energized during cooling mode, and they only modulate during cooling mode. We have 2 types of water switches. If your unit has water only, if the temperature drops below 35 degrees, we cut off compressors. If it drops below 20 degrees for glycol, we cut off compressors. And this is just a really nice water source heat pump that we had a couple weeks ago that we built. That tells you all the components which you can find. Liquid line pressure transducer, which starts at the top left. Water flow switch. We were talking about it, and we realized we put 2 water flow switches on dual circuit units. We're going to switch to 1 that's all it's needed. We had redundancy for some reason, and it caused issues.
And that is a differential pressure switch, so it doesn't have the paddle style in there.
Yeah, so it's only measuring pressure and it's factory set. You should not have to touch that switch. Three-way reversing valve, then the 3-way modulating valve, reversing valve accumulator. There you can see the biflow liquid line receiver, field water connections, the temperature switch. You can see where those are located. If the wires coming out of the temperature switch are blue, it's glycol, and if they're black, it's water. Yeah. The wires you see is blue, it's glycol, black is water. And then high gas read components. We use 2 types of valves now. The one on the right is used on the OAB, OAK, OAG, and OAN Rev 5. It's 2 separate valves that are wired reverse acting. And then we have one on the right, which is a 3-way valve we just switched to on our Rev 6 models. So only the OADG and OANG will you see this valve. What's nice about it is a really quick reference. Connection B, that you can't really see here, but they are stamped into the body. Connection B means that should be going high gas read. So if you see the B is going to the condenser, you know you have an issue, you have to replace the valve. They are Sporlan, yes. And they are controlled by the same board. So what's nice about the valve on the right, there's only 2 wires to the board. You don't have the black, white, where they're twisted and they're reverse acting. This, if it's done properly, it'll operate, you don't have to go in reverse wires.
4 wires versus 8 wires.
Yeah, 4 wires versus the 8 wires that you see typically. And then we've also got a new, Squirrel updated their high gas read board, which has a flash code diagnostic now that tells you if they're opening or closing. So that's what we're also going to include, is that we've updated to late last summer. Then cooling for the digital scroll, this is just a quick chart so you can reference. If you read the literature for Cobra compressors, they tell you that your output could be 1.4 volts to 5 volts. 2.0 volts is our minimum. We do not go all the way down to 1.44. So we've adjusted our chart that it's 2.0 volts to 5 volts within the unit. What we found is we went below 2 volts because of the loading and unloading and staying in an unloaded state for so long. We didn't get enough gas back to the compressor, caused it to overheat, and it would trip its high temperature limit. So that was a typical, that was a frequent diagnostic that was occurring that we fixed by upping our minimum voltage. And then variable speed compressor. How many have started up variable speed? How many have issues with variable speed? That's not bad.
Yeah.
That's gonna be a lot.
We don't
worse.
even tell them that.
We don't even tell you all the issues we're having then. We can just blow by these slides. No, all in all, variable speed is the future. When the new refrigerant comes, which is coming in 3 or 4 years, digital scroll goes away. Variable speed is the only thing they're optimizing. And variable speed is going to be used on most packaged units. So you're going to have a drive on all the compressor sets moving forward the next 3 or 4 years, which adds a whole other complexity to the unit. So one thing to mention, we offer variable speed in multiple cabinets. We only offer one variable speed compressor tonnage. So by saying that, we offer a 10-ton compressor, but we put it in a 5-ton compressor, or a 5-ton unit. So if it's a 5-ton unit, we go from 1 to 5 tons, and for 10 tons, we go 1 to 10 tons. So we limit it based on how much cooling they need. So the chart at the top tells you your cabinets. You know, if you've got a 5, 6, 10 ton, 12 ton unit, that's the parameter you need to adjust. Which tells you the output to the drive itself. And then the parameters, it's pretty much it's kind of self-explanatory. You've got the arrows where you see PR 07.012. All that means is I need to push my right arrow 7 times. That gets me to parameter 7. So the first top parameter is that 07.012. You press the right button 7 times. That gets you to chapter 7. And then you press the down arrow 12 times. That gets you to it's whatever the 07.12. Pretty self-explanatory. Then you just use those to change your parameters that we set.
Do you know if you're like on 10 or 11 as you're going, or you?
It tells you.
Yeah.
No, you'll see it. I mean, it's quick that. No.
Yeah, it's one of the VFDs, and once you get in there, start hitting the arrows, it does explain itself pretty quickly.
Yeah, we don't have enough of them in the plant to go over, and for me to even power that here, I'd have to bring in 3-phase, which safety would have an issue with that. Huh?
I worked on some diving equipment like that.
Oh, yeah. Oh, no, we don't do that. Yeah, we're gonna take a quick break. Then come back, and we got about another hour left, and then we'll get ready to go eat.
I don't know, you might spend tomorrow looking for a place to stay. Cause I'm thinking, they didn't give us, did we tell her we wanted to come back Thursday? Yeah. I want to ask her. They changed the max gas. Yeah. Low 5, 4. Okay. And there's
Oh, sure.
I got my ass kicked on that low pressure. That's what it is. It's just like what how it is. That's what they were using for they were using low pressure.
Yeah.
But they said
I'll tell you though, after
if they increased it, it made the low fire.
Yeah.
But the knob was small. So I just put mine up. I go on to
I built a wine cooler. It was an all-glass wine cellar for one of those type of restaurants.
Wow.
And it's a cool restaurant, right? It was funny, like 3 years later, they gave me a call from my cell phone, like, hey, I was like, nope, I don't work on that stuff no more. You can call somebody.
Where's my checkout? Tomorrow. You'd be like, dang.
Because I was ready to kill people.
Yeah. Fine. My home. What's up, bro?
You want no pictures of this stuff, man? Man. You don't want this stuff, no pictures of this stuff.
You don't want none of?
I'm trying to get that. I'm thinking in my head, you know, what's the process I have to go through to change this skin? Honestly, the easy way would be that even if it's not a published document, like I like the route of having the book that's the non-paper book. That's something that if it's a non-published document, training document, it's hard for us to tell it goes through. For one, we can't, it has to be trained enough. They only do it on certain frequencies, but if it's a non-published document and we print it on that type of paper, that's a shorter cycle that we can, if we make a change, we can get it included. So I kind of like that route, and then finding some way to fix it.
Yeah, I'll see if I have a picture of one of the chillers.
Yeah, that would be nice. Yeah.
It just makes it easier, like for me, because you can hold it in your hand and flip through it.
Yeah, 'cause I think we know that, you know, that's a good compromise on both those. There's the benefit of having it loose is that you can, and if it's raining outside, you can take it back downstairs with you and
That's another thing. Like I've taken pictures of everything and run downstairs, and I'm scrolling through my phone. When I run back up to check, if I can take it with me, and then put it back in the unit. Most train techs will put it back in the unit.
Yeah, well, I'm less worried about the train tech putting back the unit than the installing contract.
I've honestly never had an install contractor take the print out of any of the chips.
Well, and this is another one of the trying to work with production. The problem is that a lot of times opening up our cabinet, the way that we ship things loose, it's hard to identify what the installing contractor should not take. So if he can't really figure it out, you know, he may just take all of it and get rid of it to do it, and then he'll say, "Oh, I don't need."
To the door, he'll figure it out as we go in.
Yeah, so that's where I say it's a good compromise. Is that he can probably look at it and go, "Okay, well, it's probably not for me," or it's not easy to pull off. He'll go, "I'll come back to that later on." But yeah, so there's a lot of like pulling stuff out and thinking, you know, if we don't need this, we'll put it back in the unit later on, and then you know things get lost. So I'm more worried about that because we know that's an issue. But,
Well, and for our area, Harrisburg, we usually have similar contractors, chillers, and also put in the ACC, so they know how we do it.
yeah, so your area may not like it, maybe less frequently of an issue, but yeah. Yeah, I like that.
Yeah, but I'll see if I can find a picture. I'm sure I have a picture of a chiller with that issue.
Yeah, because I'll still let it. Right.
I text and email I just turned it off. It's pretty much on for like 2 hours. Hopefully I can get them back tomorrow. That's actually 5. Either high fire or low fire.
Right. There's a charge there that's on the control system.
Yeah, for the next class. When is the next class again? March. Yeah.
What's available in the space?
Might be. Yes, if I just go back early. Yeah, ask about that.
Come on. Let me look it up so I can go by and make sure. Yeah, I know. Okay, I call her. Yes. Okay, you call. So do not fear.
That's the one we had died out.
One more word.
And charge.
Four.
That's what we started.
Do not fear. Do not fear four. I can fear the ravens.
I'm thinking on Oh, about adding, removing
Do
refrigerant.
not fear, for I am with you. So simple, but still powerful. Do not dismay, for I
All right, so we're gonna go about another 50 minutes, and then the last 30 minutes, you guys can answer emails, do whatever you need, and then they'll be here so we can go to dinner. So getting back into cooling startup, we always ask, you test things at full load. The one thing we do mention is variable speed. There's a second test that has to be done for variable speed. Because variable speed is a different animal. Again, the variable speed compressor, it speeds up and slows down the motor itself, which means the refrigerant speeds up and slows down. Digital scroll, since it's on off, you have full flow, no flow, full flow, no flow, which makes it easier for us to control. However, the variable speed, once you've checked everything at 100%, we're actually now going to ask you to take that variable speed command down to 0. Hot gas reheat needs to be at 100%. Get the head pressure up to 400 psi. You can either do that by modulating the condenser fans, it's got a VFD, which they almost all do, or removing compressors based on the contactors. When you do that, your subcooling needs to be 5 degrees higher, or needs to be 5 degrees or higher. The reason why we have found out with variable speed and the reheat coil and everything, your unit requires 30% more refrigerant at part load than it does full load, which is sounds really, backwards, but it needs that because we're moving. When we're at low loads, more tubes are full of liquid. It's requiring us to have a lot more refrigerant in them. We don't have as much discharge gas going through the condenser. I mean, that condenser can have 3/4, almost the whole thing being full of liquid. So we're asking that this be done so you get proper charge, or you have proper charge during part load conditions.
So it's just making sure that we have subcooling across all conditions, all operating, because if it doesn't have subcooling, it's gonna get, flashing for the TXV, and then that's actually probably gonna cause high superheat coming back to the compressor. And the VFD is really protective of the compressor, to say it lightly. So if it sees high superheat, it'll probably go into an alarm and it'll shut off, and there may be issues there. So that's what this is doing, is to make sure that across all conditions we have adequate subcooling.
So going into gas heat, this is our 50 to 500 MVH indirect fire burner modulating. I do want to make you aware we're still messing with propane. We have very few of those in the field. Those are guidelines for the pressures. Propane, it's a difficult burner for us that we're adjusting on the fly sometimes. But for natural gas, these values are set. The one thing we're asking is low fire. How many people, what typically was our low fire is typically between 0.2, 0.3?
Yep.
We're asking low fire to be 0.4.
You changed the nozzle?
I'm sorry?
Did you change the nozzle or something?
No, we are running into issues with
See a lot of issues with the flame blowing out.
flame blowing out, thank you. It's because of that. We have determined, or we found out that the burner is only rated for 31 mile per hour winds or less. Anything above that can cause the flame to cause you to lose flame.
So now are you seeing overheating issues at low fire now?
No, it's minimal.
Okay.
From 0.2 to 0.4, we're not seeing
I thought
overheating
somebody
issues.
at tech support told me to take them up to 0.5. I could go to 0.5.
You could, 0.4 is which we're comfortable right now. Another reason why we've done this is typically we're seeing a lot of units on a site, say 10 of them. You set the gas pressure, you have 10 inches incoming, right? You set your low fire at 0.4. Well, they're all outside air. Typically, they're all going to come on at the exact same time. When those all come on at once, gas pressure in the system drops, low fire drops, you could have flame loss. So we're trying to prevent those issues also. Because we're starting to see more and more of that. We're getting a lot more orders with more units.
So I've had some of them where I've actually been on the phone with tech support, and they've gone in and changed the program because when I do that flame, when it does that, it does a flame fail lockout.
Yep.
And it locks you out in the program. I think it's programmed in TGP, it's 60 minutes before it resets.
Yes.
So 60 minutes, fucking, they're bitching.
Right.
They're freaking out on you.
Now, have we addressed that, King Will?
Is that, are you talking about, so is the issue with the flame loss, or is the issue running the supply fan
See,
with
that
no
was
heat?
another issue that brought up, because when you walk up to the controller and you look up to it or look at the TD7 and you hit it, because all it says is flame failed. Doesn't tell you why the flame failed, doesn't tell you what the problem was, just says flame failed. You go, what the fuck? So you go in and you reset it, you fire the thing up, and it runs fine. You can stand it for 2 hours and watch it, it runs fine.
Yes.
Yeah, so I think.
You're like, really?
So the short answer is,
You're like, what
Yeah.
the hell?
I mean, the only way.
No.
So I don't, that's not a diagnosis, as far as why the flame failed, I don't think that's something we can necessarily pull back. There's no information to know that. And just like what he just said, that, you know, if all the units come on, the gas pressure drops, or if the gas supply from the supplier drops down to close to nothing.
I had that happen, I've only got 2 units on the road.
Yeah, so I think, or the wind blowing it out, I think there's no way for us to pull back whether the flame has been the reason why. Then that would require pressure transducers on the gas line and other things like that. But I mean, the increase in the minimum gas pressure should take care of a lot of the nuisance trips of it.
That's what I've done to them.
Yeah, and the flame sense, which we're going to mention, the flame sense we're finding is out of tolerance for where it should be on the burner. You're probably seeing a lot more this year.
That's why I asked that earlier. I have drilled another hole, moved it.
Yes, that is our fix. The fix is moving that flame sense over. You're going to see it's off center. When you go to look at it, it's going to be more off center. That's an issue, and our igniter's an issue. The igniter's off center. What we're finding is that the sheet metal that it uses, our manufacturer, their tolerances are off. It shifted everything. When we test it here, and you have 70-degree plant air, there's no problem. When it's 0 degrees outside, 20 degrees, and your density increases, you have a whole other situation that they don't see.
When you're up there looking at it, they seem to be sitting on the left, to the far left side of the burner.
Those are being moved, and we're going to show you how to move the flame sense and a quick fix for the igniter itself. We're going to cover a little more of that today, because we're going to jump in tomorrow with more TGP. I'm kind of breaking it up I'm switching things. Again, it's our second class, so. I'm going to try to get there today, maybe tomorrow. So that's an issue. We're also going to show you issues with our combustion blower. There is a manufacturing defect with combustion blowers this year too from Beckett. How many have replaced combustion blowers this year? Yeah. So we know that's coming, which to make you aware of.
You know, those 10-degree days when you're calling back and everything, but
Yeah.
back in
Yeah. So, looking at this burner, it is split manifold. So the left-hand side is modulating, right-hand side is on-off. We asked for, so quick question. Typical sites, what is the inlet gas pressure you guys see? Is it 10 inches, 7 inches?
7 to 14.
What do you see mostly?
11.
Probably 10.
10? 7, 8. Okay, so we're trying to figure out what we want to adjust our factor to. Right now we test at 10. I'm just trying to get a feel
It's
about.
gonna be hard, man.
Yeah, it varies a lot.
Yeah, I've seen anywhere from 7 to 10.
7 to 10. Okay.
Usually if it's over 10,
So we asked for 7 to 14 inlet. Between the on-off and modulating valve, we asked for 5. Low fire is 0.5. High fire is 3.5. If you haven't seen one of these valves before, they're pretty simple to use. Basically, I'll look at it this way. Yeah, you hold the button on the left, it'll light up, start blinking. That means it's low fire. You can adjust low fire by pressing this to decrease your gas pressure. Right-hand side increases. We've included the instructions.
I think we should with the unit.
Yeah, we ship with the unit now, also. Once you're done, you hold both buttons, it's set. Hold the right, light comes on, stays lit. Press the right, it increases, left decreases. Once you get to 3.5, you hold it, and then it sets itself. So that's how you can set this valve. It's very, very easy. Again, we'll look at that tomorrow.
Yeah, so
We go to UC units.
So one of the buttons puts it into low fire, one of the buttons, the other button puts it into high fire. By holding, once you hold it into it, the LED indicates whether you're in high fire or low fire. And then using the same high fire, low fire buttons, you increase it and decrease it. To release that, you press and hold both buttons.
you don't hold it, doesn't say percent.
Yeah, it doesn't say percent. And then back to your question on microamps of the flame sense.
Yeah.
Modulating side, we look for 0.5 microamps or higher. On off side, 0.5 microamps on the left-hand side.
That's modulating.
On the modulating side, yes. On off side looks for 1.0 microamps.
What again?
0.5 microamps on the modulating side that has the modulating valve.
Yeah.
The on-off side is 1.0 microamps.
Is there a way to like reboot that controller so you can start again? You know, sometimes you can mess that damn thing up. Well, at least I do. And
When reboot the vacuum controller, the modulating vacuum.
the gas valve, just to kind of start over again.
I don't know, to be honest. So I don't know if you did just because it's got 20 volts AC with a quick disconnect, but I don't know if that actually erases it or not. I'm not actually sure if it has stores that on the side. I don't know. I've never actually tried that.
Sometimes I go too far, trying to calibrate it, and then it goes into flame fair, and I gotta re-clear it again and try to fire it back up before it shuts out.
Yeah. So I was gonna say, so what I do is like in that case where if you drop it too low and you like, or it starts off too low on the minimum fire, if you watch it and it drops out, I just increase it all the way up till it would have been like 0.6 amps or 0.6 inches rather. So I just before it tries to retry, I just keep pressing the up button and just get to the point where it's fine, and then I release it before it goes back to the next try.
So yeah, if you lose flame, it doesn't kill power. So you can start hitting the increase button, keep going until it relights, and then your pressure will be like 2 inches, and then you just decrease. Is what we're mentioning. Oh yeah.
I thought you could only adjust when it was actually calling for the heat. So you're
Nope,
saying-
you can adjust it anytime.
You can adjust this anytime.
Yep.
Yes.
That's good.
For your ILM, it says it low fire. When I looked in the ILM, it was 1.7.
0.17. Yeah.
1.7
That's.
Yeah, no,
yeah.
Well, so there. I mean, if the IOM says 1.7, then it's somebody that was a typo where somebody meant to say 0.17. Yeah.
2013.
But they want to play loss on that one.
Yeah, 0.17, 0.2, 0.25, even 0.3 you've heard from us. You probably didn't heard us come into your office and say it. 0.4 is what we're recommending now to keep proper flame because of the issues we're seeing, especially when you have 10 or 12 of these units on site. It causes a lot of problems when those don't all kick on at once. know not everyone has, but we recommend having 3 manometers when doing gas heat setup. That's the easiest, the fastest. You look at, you got 5 inches between the middle one is, so if you have heat 1 on, heat 2 on, and your heat output is 0, you should have 3.5 inches on the right hand on-off side, 5 inches between the on-off and modulating valve, and then 0.4 on the low fire. And then this is where you're full fire. You should have 3.5 your high fire manifolds, and then 5 inches between the modulating and on-off valve.
Do you ever do full modulation on both first stage, second stage?
Not right now, no. They're not listed. To do a fully modulating burner on both sides, that's not the pipeline, unfortunately. That's
You're blending
so when he's asking, what he's talking about, so this is a typical issue we've seen. If your burner is here, you have your modulating manifold, you have your on-off manifold. If your ductwork comes out and then goes this way and this way, when I'm at low fire and I have this burner on that's modulating, this path gets warm, this path stays cold. Yeah. So if you run into this application in the field where directly after the burner you have a T, you're going to have issues in a blender or something has to be installed. A blender, some type of sheet metal to do something with the air to blend it. Like an air blender, turning vanes, something. Because if not, you're going to, and then vice versa. When this burner goes to full fire, you're going to have extreme heat over here, and then it's going to be a lot lower on the left-hand side.
In addition to that too, this is why we recommend a turn before installing the discharge air sensor. That if you were to install a discharge air sensor on this side, that once that second stage comes on, it looks like your discharge temperature just shoots up. So we'd like for the ductwork to be laid out in a way that it can mix before you read your discharge air temperature.
Yeah, we like to see a 90 after the unit, and then 4 feet down the ductwork for my discharge temperature sensor. That's the best practice. That will cause, that's the best so you don't have temperature swings. The program's not hunting. Again, he said if you have a temperature sensor here, it causes all kinds of issues. You'll never ever even out.
we don't design it, we just start.
No, and it's another. We're trying to come from the other side also, because we have to deal with it too, and getting this message out is not always the easiest, unfortunately.
Trying to get some type of air blender where you got no room, what I mean, it's just.
Pain.
Yeah, it is.
One
back, somebody's gonna say, well, how come nobody told us that? You guys should know.
If the unit can handle it, which it probably could, that would work.
I see that line.
You can't. Yeah, we don't have a good solution for this. We don't. And the problem is Aon and Dyke both have the same issue. And I don't know how they communicate it properly. I don't know if their sales guys understand the duct layout, they look for it. I can't tell you how it's done.
Find the sweet spot with the sensor, multiple positioning and.
They also need to put a turning 90, put veins in that damn thing.
Yes, veins in it would be helpful also.
Yeah. I've had a couple that don't have veins in there, and it's all over the freeway.
And I think we tried an averaging sensor across it before. Again, I don't think that worked as well, because there's only so many points that averaging sensor picks up. Honestly, just getting enough turbulence down the ductwork and getting a sensor farther away is the best.
So what do you guys say, what's the deviation between, you said 3 degrees plus or minus? Is that what we?
We like to try to say 2 to 3 degrees, yeah.
And some emission gauges will hold you to that. You don't see it if we're ever trying to get that.
So is that just, you're talking about for the unit to maintain that temperature? Yeah, I mean, I guess it also depends on what, there's a lot of variables play into that. I think a general statement, we could probably say that, but
So, yeah.
Because we've had people ask similar things of, you know, there's genuine people on the extreme end who, with no hot gas reheat or little hot gas reheat, or they have fixed speed compressors. They've got 2 fixed speed standard scope compressors, and they want to maintain plus or minus a couple of degrees. So it's sometimes there's enough equipment selected, and then even with the gas heat, that if you're at the point where you need that second stage of gas heat, the first stage is at minimum is still too much. You know, there's a minimum temperature rise that you get off the gas heat. So there's going to be some conditions on the outside area that it's going to swing a little bit more than others. So, you know, there's not always the case. Even if, you know, if you need 75% of the heat, we can probably maintain a pretty precise temperature if it's on down the ductwork, but that's not always the case.
So a big issue with that statement at 2 to 3 degrees, while we mentioned where it becomes a problem. If I have a 2,500 CFM unit with a burner that size for 300,000 BTUs, that's a 100-degree rise, which is our max. The max tip rise we can have on our unit is 100 degrees. Well, we have a 10-to-1 turn down burner, which means the minimum rise is 10 degrees. So what's going to happen, min rise, when my modulating burner goes to 100% or is at full capacity, and I switch on my on-off, this goes back to min, but I have a min 10 rise. So I'm automatically going to jump up 10 degrees when I'm switching between heat 1 and heat 2 coming on. So that's where that 2 to 3 degree rise becomes an issue. That it's very hard to control because of the way the burner is set up.
And included in that is, if you look at the, so if you got where over time, this, let's see, basically as your temperature starts to when you turn that burner on and it starts to go this line, that's a 10 degree rise, your temperature starts to go, your delta starts to go down toward that over time because the heat exchangers have to cool off as it ramps down. So if you're staging on that second stage of gas heat and the first one goes to minimum, there's a period where it's cooling off. But at that point, it's kind of already overshot the discharge at that point, and so it's going to, and within a couple of minutes, stage that second heat off. So there's a period of time where maybe we can get down to 10 degree rise on that modulating side, but it takes a period of time for it to get there. And by that point, the unit may already make adjustments.
Basically, when we turn heat 2 on, it takes 3 to 5 minutes for everything to stabilize before it's all going to even out. Because of these tubes being hot, these tubes being cold, you got about a 5-minute adjustment before the PID kicks back in. Just something that we wanted to bring to your attention because we had a lot of questions on it. This would have been on the big OA and Drive 6s, your 80 ton. Did you have a large heater in an 80 ton?
It was straight air.
It was, sorry?
Straight air.
Straight air. So in the 80 ton units, we have a very large burner that's up to 1200 MVH. The only thing I really wanted to point out to you is that the top burner, which has the modulating side on the left and the on-off on the right inducer is what comes on, not the left. So if the left side is, you have ignition, it's because the right inducer has to be on. It's not the inducer right under it.
Makes sense.
Right, so that's it.
Obviously.
Yeah. Just FYI, and the way it is, it's the way that's tracked, yeah. Cause we got pulled to the production floor and we were stumbling with the tubes, we forgot how this worked. But yeah, the left-hand side modulating is controlled by the right-hand inducer, not flip-flopped. So you're going to be seeing more and more of these units being shipped out. Our goal is to have 2 of these built a day starting in the middle of summer. So we were only building 1 a week this past year. So we're pumping these things out like crazy, right? We're starting to pump them out.
Have you seen any with
712.
heat exchangers piped and the airflow, obviously?
Pretty much, yeah. The way it looks. This one. If your tubes are here, I'm just going to do it first, and that's the manifold. It kind of goes like that, and then there's the opening for the inducer. So it pulls air that way through these, and then you have the exact same effect on the bottom, where it's pulling down all this side. So that's where it gets a little confusing. And you're going to see more of these. Again, we're going to be building two of these a day come next summer. And they go up to 80 tons, 25,000 CFM, and 20 horsepower motors with 25-inch wheels. They're monsters.
You guys putting compressors right for these?
They are. No. I'm sorry. No. Yeah, you caught me off guard. When you did this, I was thinking that all compressors on the OA and Rev 6 are on the bottom shelf. The heater actually is turned.
It's almost vertical.
Yeah. So it's really weird. We'll go out and look at one. But if this is my control section here, and my compressor sit down here, the heater is actually inserted on this side, and the tubes go this way. The tubes are about 3 times as long as the ones you're used to. These are very large diameter tubes. They burn at 75,000 BTUs per tube instead of the 25,000 BTUs per tube. So these are monster heaters that are going in there. They're very long. These tubes are 110 inches long.
So have you seen that pressure switch in the top right corner? Where the flue gas comes out the pipe? That pressure switch is mounted on a bracket, and the bracket is the way it's bent, and they mount it in the unit. It's actually laying up against that flue vent, and it melts the switch. I mean, 2 or 3 of them like that.
On this exact type?
Yep.
Okay.
And I had to go back out once I found the first one.
Another one for the punch list.
Once I found the first one, I opened them up. I'm actually taking that switch in the bracket and bending it away from the blue pipe, because it's laying right up on the blue pipe.
Okay.
And when that burner fires up, it's like, holy shit, man, the wires are on fire, the switch is melted.
Yeah, that's how tight it is, isn't it?
And just for full disclosure, we've also got a quality problem with our insulation, but also the wires themselves. Those control boxes come to us loose. We're mounting them. Well, we did not secure those wires properly to the manifolds. They are laying right across those tubes. So when you go to start up a unit, please look at our gas train, because I'm telling you right now, the wires are laying right across those engines.
They're all laying right in the burners. Every one I started up, they're in the burners. I've been zip tie everything out of the way.
Yeah. So we made an engineering change, said we want the boxes so we can move them left or right. Well, we made that change, we never realized until production how to actually route the wires. So that fell on us, and now we've got a lot of those in the field with that issue.
Even the condensing tubes are laying in the burners.
The condensing tubes laying in burners, they may not be there at all.
Yeah.
So you also need to look at the condensing tubes. You found a screw inside the inside?
It was glowing red hot. I looked in and I saw the screw glowing.
Okay.
Yeah, because we built the burner.
We built the burner here. You drill this way and then turn the burner 90 degrees. I can see how that happened. We just started doing that. So
One thing at a time, all right?
How much time you got?
So the good news is I've got some of the supervisors and line leaders, our tester, refrigeration guys, they're all going to come in tomorrow for lunch. So you guys can, talk to them, and they're going to tell you what they're working on and how we're trying to fix this. I mean, you gotta understand, we've grown 30% every year, year over year, right? So last year we did 60 million, we grew 30%, we did 90 million this year, and now we got to do another 30%, 120, 130 million this coming year. It's very hard for us to keep the quality up.
Did you say at the beginning of this class that KCC was employee owned?
We are employee owned. When I first started, we were a $20 million company. And there were only 75 to 100 employees, now we're 600 strong.
Because I've heard rumors internally in Train that they've tried to buy KC numerous times.
They have not tried to buy us, but we are more integrated than ever with them.
So who owns who? Is it still KCC owns themselves and they own them?
Correct. We are our own company. We're an employee-owned company. So we strive to make it better. But with our explosive growth we've had, we've had double-digit growth for the past 8 years. And so we bought this building. We came here last year. You'll see it. We're actually almost at max capacity. This is supposed to be our 5-year plan. We're now starting to plow the next other field. We built another manufacturing facility.
Yeah, and you can see a bit of it. I've made a joke to somebody at the last training that we're like a lot of other manufacturing plants. We ramp up during the summertime. So you'll see like during the wintertime or during the summertime we hire more people and we have new people and maybe they don't really understand how to do something correctly, and then over the summertime, we build up a few of these quality issues that kind of appear, and then it's like over the wintertime, we play whack-a-mole, and we're knocking all these down as people become more experienced. So you'll see a bit of a trend when we have 30% growth every year. You'll see towards the end of the summer that we have more of these tiny little quality issues that kind of pick up, and then we try to squash them. They end up getting squashed over the wintertime. So, and that a lot of that is because the growth we see in the summertime when we
It
shoot up.
happens in every industry.
And it kind of falls on us. We hear the complaints. Our team has to communicate together. Didn't realize that you guys are saying the same stuff, and then we have to go try to fix it. The problem is it happened 6 months ago, and we have 6 months worth of issues that we have to go back and correct. Just like with those TR150s, I had the right parameters. 300 of those got out before we realized we had a problem. That's how fast we're moving, and we're doing better.
Quick.
Yeah, a lot. Well, we're investing in our own, at our other facility, our own testing lab, this and that. We're slowing things down. It's not making Train happy, but we're trying to get quality under control. Our quality's expanding, they're working with us. We just never had that, and our growth is just, it's hard to control sometimes.
That's good, though.
Yeah.
That's good.
Well, and unemployment rate here is 3%, so finding employees in general to man everything's becoming a problem for us.
3%.
Yeah. The partnership started in 1986, actually. Honestly, our owner at the time actually used to work had his own, was Kentucky Train, and was a train dealer. He lost a job to an adapter. It pissed him off, so he lost the job of an adapter to his country club. It pissed him off so bad, he started a curb company. And then our curb and adapter started, and then we started modifying RRUs for train.
That's where I had first heard you guys, Kentucky Curb Company.
Yeah.
Yes, because we have a field support side that's kind of unrelated to the train product, and then we started building the curbs, and then after the curbs, we started modifying train units, and then in 2010 or so, that's when we started building this product line.
So I was doing national accounts, I would see that KCC curbs everywhere.
Yeah, like the Walgreens and things of that nature. Yeah, we had a lot. KCC curb was, without that, we would never have had a Horizon, without curb and adapter. So it's still a big part of us, it's just that other facility. This place is only Horizon. So, and we actually used to do sheet metal for Lindhaven, do parts for them. But we do all of our sheet metal in-house now.
And Jordan and I both started right around the same time, right around when we first started this product. So we've been here just about 10 years, and we started the product just about 10 years ago. And
2010.
Yeah, so this is part of the reason why I think we're particularly passionate about the equipment, and we really put a lot of effort into trying to make the equipment better and easier for you all to operate, because
This is all
we've been here since the beginning. So
it's the only unit we work on every day. So.
yeah.
All right, back to. It's just to tell you how the startup is, which you should read, or how the sequence goes. I'm not going to go over it, but this is, if you call for heat, this is the sequence that it goes through. It's not really thorough in the IOM. The modulating board wiring diagram. W1 to the left is the call for heat 1. Inducer command, we go low speed, high speed. Does anyone do most any of our controls with the gas heat, changing controls in our gas heat sequence? So the reason why I mentioned that is we call for the inducer to go to high speed when our gas valve is above 20%, correct? If it's above 20%, the inducer has to go to high speed or you have a flame rollout. If second stage is on, we're at high speed. So that's just something that you want to be aware of. If you're making changes to our heat TGP, the best thing to do is just always jump inducer out to high speed. Don't even worry about trying to make that control change. Honestly, if you look at on the right-hand side, not the contacts or the poles of the relay, but actually the board. If you put a jumper between W1 and W2, that will cause the inducer to come on anytime you have heat 1 on. Another thing I want to mention is that we monitor the gas valve on the modulating side. We monitor to make sure it comes on. If the gas valve on the modulating side does not make, you will not get a call for heat 2 or heat 3. So it's a safety. If the heat 1 goes down, we kill all heat in general. Just because we don't know what's going on, it's just to protect the unit.
And that's also what we get back as a feedback status as to if the gas heat's running or not. It's about wiring through that relay.
Yeah. If we call for heat, gas valve relay is not made for 30 seconds. Is it 90 seconds?
Yeah, something like that.
Yeah, I think it's 90 seconds. If our gas valve really doesn't make it to 90 seconds, we know we have a heat failure, we throw a diagnostic now. And another thing that we will talk about, but we should go back to, the new programming, our diagnostics within UC is about 6 times the amount what's there now. So we put a lot of thought into figuring out to give you more diagnostics for trips and things of that nature.
Yeah, so the heat failure also, so we've only done this for the gas heat up to this point, but the electric heat, we're also, for our enable and the gas, or the electric heat safeties, we also do this, add the same relay back, so we'll also have the heat failure diagnostics on units with electric heat. So it won't be just the gas heat moving forward.
Flue extenders, you still.
Yes. So the flue extenders, there's a couple things with that. The flue extenders are used, one to get it above the height, the other is for wind. We have designed now a shield that is not needed with the for flue. We can build a wind guard instead of getting the flue extenders. So you don't have to install those monstrosities. We tested it with leaf blowers in South Dakota. I'm not really joking, that's actually true. We were actually using 50-mile-per-hour winds with leaf blowers, and we could not actually get those, we could not actually cause the flame to go out. So we had designed sheet metal block-offs or blank-offs that prevent the wind from hitting it from every direction, instead of using those big flue extensions.
But the flue extension was also not to recapture product, exhaust, products of combustion, too, so. Did you eliminate something and correct something else, or? Remember the site that you came up to visit one year, they were like back to back, and the customer didn't want green traffic of combustion products.
We haven't seen that a whole lot. I think it's just on the regular, with the regular layout, like going back into the, is it going to the inlet of the unit, or is it going into?
Well, they were put, the way they were set up was, the inlets were opposite of each other, but because of the winds and the building setup and everything else, the customer wanted to ensure that we weren't getting products of combustion, re-entered.
Into the space though?
The first phase, yeah.
Okay,
That's why we came up with that third generation,
Flue extension.
flue extenders, yeah.
No, if you have those, if you're worried about combustibles that nature, we do the flue extension to get it above the roof of the unit itself. And we've also done that if they put the inlet, you put the combustion here and an inlet of another unit here, we do the same thing. That's our recommendation. There's no other option for that. But the third generation flue, we still use that one. We know it works. Malinky, right? Is that the name? Malinky? That was propane. That was the rough one. So.
and one other note too is that we talked about the inducer, the cost of the inducer. Some units that we do offer with no controls, we said we hardwire in safeties on top of our regular safeties, is that we wire basically that inducer relay right there just gets removed, and we just keep that jumper in there. So as soon as they call for heat one, inducer fan just runs at half fire or at half.
So no controls, there will not be a low inducer. It really doesn't kill the turn down. It probably goes like a 9 to 1 instead of 10 to 1, but it's never, it hasn't been noticed. And then this is just the heat 3, the on-off, just a full modulate on-off port, so that people understand what's going on. We can sometimes double stack our heaters themselves. And let's say I have a 800 MVH heater. Here's my 400 split manifold. This is modulating. On off. And then we have another burner that is full on off at the bottom. So these are 400 MVH, 400 MVH. Heat 1, heat 2, heat 3. If I'm calling for 0 to 25%, I modulate this from 0 to 100. If I need to go above 25%, this one comes on. This goes back to min. If I modulate this back up to 100% where this full burner is at capacity, I need more heat, this goes off. This comes on. This goes back to modulating. So that's where this graph is kind of showing you with 50 to 74%. Because this can take up 50% of my capacity, this stays on, and then I modulate this for the other 25% that's needed. And then when I go above 75%, this comes back on, this goes back to min and then modulates.
It almost acts like 4 stages of heat, but it's 3 burners.
It's 3 burners, correct, with 4 stages. And tomorrow we'll go over, we need to add is going over some of the heat stuff, where we modify, where we maybe increase or decrease P gains. Because there is some, we've had issues with these overshooting and undershooting in the field. The dual burner setups are a little tricky. So. Again, if I have a failure on this side, the modulating, we shut off all heat. It's all gone. Done for it. Unfortunately, it's just safety. This has the most sophisticated controls, so if something's wrong with it, I just want to kill it all. Electric heat, real quick. We don't have the power to test auto electric heat full capacity. We turn it on, make sure all the contactors pull in, but some of the heaters that we get ordered are 179 kW, 208 volt. So they're 400, 450 amps, 500 amps. We can't test them all. So we ask for you guys is one, check all the connections first before you start them. We do that here. Most of we should be doing that here, but just do it also after transport. You just want to check phase to phase, leg to ground, override the heating output to command to 100. If your amp draw is 10% over or under the nameplate, give us a call because there's an issue. You should be within 10% or less. If not, we will be sending we will have to troubleshoot it with the wiring diagram. We have not had this problem yet, but we've had it here on smaller heaters at the plant we've had to go through. One other issue that we've had that is a quality alert is your dip switch settings here. The one that says test and control, units went out with the test on and not the control. If test is set and you turn the heater on, it looks like it's going to be doing everything okay. It is not controlling at all. It's just pulling in contactors. It's not actually doing anything. It's just testing itself. You have to make sure that dip switch is set to control. That is something I don't know how many units got out like that. I just know we've had it pop up in the field on numerous occasions. That's good. You've seen everything else.
Yes, so usually we don't get that.
Typically you see one of that. Yeah. This is our duct pressure transducer. Dale hit on it briefly earlier. We set this duct pressure from 0 to 2 inches from the factory. If the set point of the field is between 0 and 1.5 inches, you're fine. You don't have to do anything. Anything above 1.5 inches, we ask you to set our in the middle where it says R1, 2, 3, 4, 5, R5 needs to be set. Then you be turned to R5. That makes the pressure transducer from 0 to 2 inches, 0 to 5 inches. You'll need to go in and configure that point in the duct static pressure local analog input and just set that from 0 to 5 inches also. So if you change the setting on the pressure transducer, you got to change the configuration file, which we'll do tomorrow also. Sorry.
So do we get we've only seen a VAPI controller. Is this the same thing?
This is this one's coming. It's a newer one.
Oh.
This is we made this change in November. The other model is extinct. This is the new VAPI.
That's going to replace the VAPI?
Yes, it's the same form, fit, function pretty much. It's just got different dip switch settings.
And it is a VAPI.
It is a VAPI sensor. It's the same one. It's just their newer model. So it's just
VAPI. And then also,
I've had a couple of those fail. The blue ones.
yeah, this is blue also. Same, looks just the same.
Or when I go out for the startup, wire them in, check the dip switch, make sure the setting's correct over there. Take, like you said, come back a week later or a couple weeks later, the customer calls and units either run wide open,
Yes.
or it's not doing nothing.
Right. So that's that for the sensor to fail can cause that, and also not changing this configuration file. I'm not saying that was the issue, but if you don't change that configuration file and you have it set point at 2 and it's set at 2, it's going to run wide open, blow up ductwork, everything, which is why we're trying to highlight this.
So I go back up and when I look at that, the other one has an LED display on it.
Yep, this one does too.
The LED display is blank, there's nothing on the screen. I'm like, what the hell?
so with that, with the next program, whenever you change that, something I just added to it is that this maximum value, you'll have to, in the new program, if you do adjust the setting, you'll have to change the maximum value to just above the new number. And the reason why that is because I've also because part of that reason is because of the diagnostics that I've added to the new program is that let's say the range is still 0 to 2 inches. The program reads what the maximum value is. If they put a set point of 2 inches in there, the program's going to read and say that basically the set point is too high. It's going to have an informational diagnostic. And it's going to default back to 1.5 inch set point instead of 2 inches. So basically if they try to put in a set point higher than the sensor's actually reading the range, then you're just going to give a diagnostic and fall back to a different set point. So that way it doesn't, if they have a set point of 2.5 inches, and the transducer is still set up for 0 to 2, the spot fan is going to ramp them, and you might have 5 inches in the ductwork, and the spot fan can't know because the transducer is at maximum. So in order to prevent that, we're adding a diagnostic for that point. And we also, there's a few other diagnostics that if it's not reading quite right, that it's going to have some checks to make sure that transducer is reading correctly.
Because we've had issues with blown ductwork. If the high static pressure switch isn't added into the safety circuit unit. Just real quick, space pressure control, if you have to do it, you want to configure that point. We'll go over that tomorrow. And the last thing I want to cover for the day, this is becoming more and more prominent for us. Has anyone seen a unit that's got 2 return ducts to it?
Just started one up, and the frickin' contractor put the sensing tube in the wrong frickin' duct.
So that's going to cause problems.
He put it in the wrong duct, and the frickin' power exhaust ran at 100%. And I'm like, what the hell's going on? I'm looking in the unit, I go, I got a split duct, and I went downstairs into the gymnasium. I'm looking at the thing, and I tell the guy, you got the sensor in the wrong duct. And he's like, no, I don't. I go, bullshit.
So what we're seeing more in the field is we're going to have an exhaust path and we're having a return path. In all reality, my return path should be able to go straight to the supply. Exhaust goes to the exhaust fan. Problem is, making sure that we don't have any exhaust go back into the return, because this is coming from toilets. And we don't want any of the exhaust there from toilets to go back into the space. So what is happening, and you'll see it, what's the point called? Split return
Something like split exhaust return damper or pressure. So it'll say split exhaust and return in the point name.
So our exhaust fan is going to modulate, it's going to ramp up and down to maintain a positive pressure between those 2 points, between that damper. If it's not positive, then my supply fan is pulling more exhaust air back into the building. I want the exhaust air to overcome the supply fan and keep exhaust. I don't care if I pull more return air than needed. I need to make sure that the exhaust does not go back in the wrong direction. Does not go back in the wrong direction.
When that is doing that, does that alarm that sensor that you can't get to? It's like down below that damper. There's a sensor in there. Because I called about that sensor, a unit, another site just like that the damper was loose, the actuator was loose on the damper, and we were leaking by, but it kept logging on that sensor. And I thought it was the sensor. I kept asking the guy in tech support on the phone. He goes, you can't even get to that sensor. And when I pulled the side panel off, it's all foam. There's no access in there to where that sensor is mounted. I'm like, holy shit, how do you get to it to even verify?
Yeah, some of the units, it's hard to access that. Which parts are put in the control cabinet? Honestly, I don't really have an answer for that.
I've seen a lot of shit in the last year. All the crazy
He must
stuff.
remember the OED Rev 6 if you remember that
He's
call.
the OAD Rev 6. Yeah, I know what Clark's talking about. Because we didn't have an answer for you. Didn't have a good one at the time anyway. Don't have one still.
Yeah, because in that cabinet, it's hard to access everything behind that.
Yeah,
The cabinet's
you
visual
can't
access.
get to it. I had all 3 panels off to one side, and I'm like, well, how the hell do I know if it's the sensor? there was really no way to test it.
We're gonna understand location plus sensor. And then part of what makes this difficult is that this is rare that we get,
Yeah.
one of these a month. if
Because
that.
of the split duct, you have no way to, where that sensor's located. And that's
So-
what I kept asking him in tech support, well, how the hell do you get to it? If there is a problem down the road, how do we get to change that sensor? Because you can't get in that panel, you can't, the ductwork blocks you off from the other side panel, and the filter panel with the recovery wheel blocks you off from the other side.
Yeah.
So you have no access to that sensor and its location at all, ever.
Okay.
That's an issue.
Yeah, if it fails, you're never gonna be able to
If it
replace it.
fails, you're screwed.
If it fails, you're getting exhaust back, you're getting exhaust back into the supply.
Yeah, and then you can't get to the sensor to change it, you have no access.
It's just two more tubes that actually put away location.
Yeah.
If we can get the pieces right, I can't wait to add this one.
Yeah, that's what I'm picturing, is that we could probably, the best way to panel mount that sensor, because there's no location back there to mount it.
No.
And that just means there's two more tubes going back there for them to cross up with something else. But I think hopefully having the color tube can help.
I had tech support on the phone, driving 30, 40 minutes over that issue, and that's what I kept saying. Well, when it, when we figured out the problem, but it kept happening, when it does fail.
Yeah, because I know, I think I'm pretty sure I was on my call with them, and they kept asking me, like, what do you consider? What is he supposed to do? What is he supposed to do? And I'm like, I don't know.
So guys, the transport should be at 30 minutes. If you have any more questions to ask us, you can come and talk to us. Or if you have anything else you want to ask in front of the class. Again, I hope you guys are full hungry. The dinner tonight is great. Drinks will be on us. Also,
How many? You're gonna
I
live
don't know.
They don't count.
They don't really count, so just have a good time.
Can we leave this stuff here?
You can leave the stuff here, it will not be, trust me, it's good.
All the way to the tea y'all want.
All right.